All right, so now we're back and we're here and we're actually going to apply the triangle inequality theorem. And it states that the sum of the lengths of any two sides of the triangle must be greater than the third. All right, and these are all possible combinations. All right, so that seems a little dense, but really it says any two sides. What we can say is the shorter two sides. So to confirm what we're about to do, just pick the shorter two sides, and it must be greater than the third side, which is the longest side. So here's some problems. So hypothetically, if we had side lengths 2, 6, and 11, would you be able to make a triangle with a side length of 2, 6, and 11? So we're going to pick the two smaller sides. I'm going to do 2 plus 6, which equals 8. Now, notice how 8 is less than 11. It's not greater, so can't make a triangle. Can't make a triangle. We'll just say too short. The two smallest sides are too short. Now, in this case right here, you have 8 and 8. Those are the two smaller sides. 8 plus 8 equals 16, which is greater than 15. So yes, can make a triangle. That was very short-handed writing. But yes, you can make a triangle with side lengths 8, 8, and 15. That would be some kind of isosceles triangle. And then right here, we're going to pick 13 and 16. 13 plus 16 equals 29. And notice how that equals 29. So, can't make a triangle. This would be a line segment. When they're equal, it's a line segment. All right. So that's the triangle inequality theorem. The two smaller sides must add up to be greater than the longest side. That's how you check. All right. Now we're back in the gizmos. We're going to do side angle relationship. So we're going to turn off compare sides. So that's already off. Turn show side lengths. That's on. And show values. All right. So we have the values of the sides. And we're going to select show angle measures. All right. So that's turned on now. All right. Let me get a different looking triangle here. All right. So we got a new triangle. All right. So we're going to just randomly make a triangle. This is what it looks like. Cool. All right. We'll make it look a little quirky. All right. So we're going to list the angles in order from smallest to largest. All right. So the smallest angle is angle A. The second smallest angle is angle B. Kind of went in alphabetical order. I didn't do that on purpose. Interesting. Okay, so that's it. Those were the angles from smallest to greatest. A was 43.62 degrees, B was 50.28 degrees, and C was 86.1 degrees. Now look at the side opposite of each angle. All right, so what is the side length, or what are the sides opposite of the shortest to largest? So the shortest side, I'm going to write it like this, is BC. BC is the shortest side, but remember we can call that side A. Next shortest side is AC, which we can call B. And then next is the longest side was AB, which we can call C, lowercase c. All right. Well, notice this. From smallest to largest for angles, it was angle A to angle B to angle C. Similarly, it was side A to side B to side C. Wow, interesting. Compare the order of the sides and angles. What did we notice? We're right. Smallest side is opposite. Here, let me zoom in so I can write more. Is opposite smallest angle. My handwriting's a lot nicer when I zoom in for some reason. I'm not sure why. And then, so smallest side is opposite the smallest angle. And then the mediums up all the way to the largest, so we'll just write largest side is opposite largest angle. All right, and then by default, the medium side would be opposite the medium angle. So that's actually how, this is actually always true for any triangle. The largest angle of any triangle is always going to be opposite the largest side, and the smallest side is always going to be opposite the smallest angle. All right. So, just some more things. An isosceles triangle has at least two congruent sides. What is true about an angles in an isosceles triangle? Well, this is how we know that isosceles triangles also have two congruent angles, because if there's equal side lengths, like it's going to be really hard to do this in a gizmo, but I can get pretty close. I might have to call it quits. But anyways, both sides, there's two sides about 43. And notice how they're two angles really close to 67. One's a little off, it's at 68. Oh, there we go, that's pretty close. Two side lengths at 43, two angles at 69. That's almost an isosceles triangle. So an isosceles triangle has two congruent sides. It has two congruent angles. And that's because of what we talked about above. I'll just put an arrow to see where the largest angle is opposite the largest side. So if sides are the same, the angles are going to have to be the same as well. And similarly for an equilateral, we've talked about this a lot. I don't know if I can make an equilateral triangle in this gizmo. It's going to be pretty hard. I can come close. All these are side lengths of 30. Notice how all the angles are really close to 60. So an equilateral triangle has three congruent sides. What do you think is true about the angles in an equilateral triangle? Three congruent angles. Why? We'll just put an arrow back up to C. All right, let me check this in the gizmos. Okay, we will. All right, and to summarize, what have we learned in this activity by completing this statement? All right, in any triangle, the longest side is opposite the largest angle, and the shortest side is opposite the shortest angle. Or we can go the other way. We can say the largest angle is opposite the longest side, and the smallest angle is opposite the shortest. I probably should have said smallest angle above, but oh well. All right, stay tuned for